We're good! Woohoo! Welcome everyone, in person and online, to CactusCon. I am so excited to be able to share with you container scanning, run fast and stay safe. Container scanning is really cool, and let's talk about how we might get container scanning in place. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it's never worked out for me very well either. Which is why you can go to robrich.org. Let's go there. We'll click on robrich.org, and we'll head here. We'll click on presentations here at the top. And here's container scanning, run fast and stay safe. The slides are online right now. Woohoo! Achievement unlocked. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZGiveCamp is really fun. AZGiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. Come join us the next time we do AZGiveCamp here in Phoenix. Or if you're connecting from far away, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro microservices in .NET 6. This one just came out. Grab this link from robrich.org and it'll send you straight to Amazon. That is a fun book. Sean and Matthew and I worked on that. It worked out really well. Some of the other things that I've done, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my coveted .NET Rocks mug. And if you'd like a .NET Rocks mug, post a comment on, no, I'm just kidding. They actually don't give away .NET Rocks mugs anymore. They give away music to code by. So, container scanning. We talked about this guy. Doesn't Kubernetes just do this for me? Isn't that why I containerize things, so I didn't have to worry about the security piece? Well, kind of. Here's an outline of Kubernetes. And when we look at this diagram, we kind of squint real hard, and it's like, What we see in this diagram is the control plane on the top and the worker nodes on the bottom. Control plane in green and worker nodes in blue. On the top, we have an API server. When we're using kubectl, kubecontrol, kubectl, we'll connect to that API server. The API server will then save things in etcd. The scheduler will notice through the API server that various etcd things, or the controller manager will notice various things inside etcd have changed, and will tell the scheduler to go kick off things. The scheduler will move now down into the blue section where we have a kubelet, and the kubelet is responsible for starting a process, starting a pod, starting a container inside of Kubernetes. As users come in, they'll hit a load balancer. Eventually, they'll end up on kubeproxy, and kubeproxy will then route that content into the particular pod or container that is running our workloads. And then we might have CAdvisor or other monitoring tools to be able to look at how Kubernetes is running and keep track of how it's going. Now that's great. That's a really cool architectural diagram of how Kubernetes works. What we notice is that Kubernetes is really worried about protecting Kubernetes, restarting processes when they're not running. But there's nothing about security baked into that process, nothing about protecting our process. Okay, so if it's not in Kubernetes, let's look in Docker. Here's Docker, and we've seen this diagram where we're comparing Dockers to virtual machines. On the left, we have a traditional virtual machine set up. On the right, we have Docker. We can talk about the different hypervisors that we have, where on the left, we might be using Xen or VMware, and on the right, we're using the Docker hypervisor, the OSI compliant container runtime. And then we can talk about how we have guest OSs versus just virtualizing the operating system and just having the content for our particular container. Yeah, we do have a sandbox. We do have a unique host name and IP address for each container. To be able to interact with other things, we need to reach out on the network. We're not just reaching into other processes. We have sandboxing, but once I have a process running in any container, I can just use network discovery to find all the other containers and start pivoting into those containers. Yeah, Docker, again, is going to protect Docker, not protect the workloads running inside of our containers. Kubernetes. Kubernetes is basically a cluster of machines where it takes care of keeping its microservices running. If we want to think about it in a security context, we might think of it as a firewall in front of our containers. Yeah, we're kind of misusing kubeproxy and the API server in that respect, but at best, it is a firewall. We're only getting the particular traffic on the particular ports that we've subscribed to, but we're getting all of that traffic. Kubernetes can't secure the process in the containers. Kubernetes focuses on securing Kubernetes. By comparison, when we look at Docker, Docker has a file system, it has users, it has processes, it has ports. Wow, this kind of looks familiar. This looks a lot like a Linux machine. A Linux machine has users and ports and processes and file system. So yeah, there's a lot that we can do to secure our container process in the same way that we would think of securing a Linux machine. Well, kind of. A Docker container is a Linux machine, except for it's ephemeral, isomorphic, and deterministic. It will start up every time. It's designed to be short-lived, and it's designed to get killed off and restarted. As we build one, we're going to build it in the identical way every time. We have short-lived, unchanging, and identical containers. Ephemeral, isomorphic, and deterministic. So some of the techniques that we might use to secure containers might be different than the techniques that we would use to secure a typical Linux machine. So by default, every container can communicate with every other container. Yeah, I just do network discovery, whether I'm on Docker or on Kubernetes, and I can just discover all of the other IP addresses, and I can launch attacks at those other containers. The moment that I get inside of a container is the moment that I can pivot to every other container. Oh, but we have Kubernetes namespaces. I can't launch a process in a namespace that I don't have permission to. Yeah, but once I do launch the process in a namespace I have permission to, I can then pivot to all of the other namespaces. Namespaces are an organizational boundary. They are not a security boundary. Yeah. So how do I secure a container? Well, it's interesting. If I can pop any of the containers in the stack, I can now pivot to any other container in the stack. When we take a look at threat vectors towards containers, we can kind of think of things, a CVE and installed software, maybe a custom app has a vulnerability, maybe it's excessive permissions, maybe my app is running inside the container as root, maybe I've exposed secrets. We can kind of centralize these into maybe two major attack vectors, something from underneath and something from outside. And then, once they're in, either from underneath or from outside, what can they pivot to? Well, we've seen that once they take down this container, they can pivot to all the other containers. And so now they can continue to attack other things. So the good news is now when I have an infected machine, an infected container, it's ephemeral, isomorphic, and deterministic. Its goal is to get replaced. So I just fling off that container and I spin up a new one and the infection is gone. In that container, it may still be in the cluster, so I may have to spin up all of the containers anew to be able to rid myself of this. And to that end, is the infection pivoting around my containers? Maybe I need to shut it all down and spin it all back up. Or if I'm using infrastructure as code, throw away the entire cluster and spin up a new cluster to be able to get rid of the infection. But I don't need to scrub my machine. I don't need to run a virus scanner on my software, on my container. It's not designed to work that way. So how do we test our container, validate that our software works as expected? We might run unit and integration tests. We might run static analysis on our source code. Maybe we're doing a machine inventory for known vulnerabilities. Let's identify all the software running on our machine and compare that to a vulnerability database. We probably need to do open source license validation. Let's go collect all the licenses of all the packages and validate that we're not exceeding any of those licenses. And then ultimately, we'll take the results of those 4 steps and we'll give ourselves a go or no-go scenario. Let's validate this against our corporate policy. Unit tests, integration tests. There's not much that I can say about this. They're important. You need to do it. Moving on. Static code analysis. I'm not here to sell particular software, but as you grab these slides from robrich.org, you can click on any of these blue links to learn more about these particular software, and maybe that will give you the search terms that you need to be able to discover the static code analysis software that works exactly as you expect. Next, license analysis. Here's some more software packages that'll get you those search terms. White Source and Black Duck will get you to the point where you can discover other pieces that may exactly work for you. So we've run our unit tests, we've run our static analysis, we've done our license analysis, and now we go into this go or no-go scenario. So let's take the results of the unit tests, let's take the results of our license compliance, let's take the results of our static code analysis, and let's decide if the software is good enough to deploy. Now, it's really easy at this point for us to go, hey, if there are any vulnerabilities at all, if there are any failing tests at all, we should not deploy at all. Well, what happens if I have a situation where there's a disease without a cure? Should we not deploy what's better? It's hard for us to say we shouldn't deploy at all if there are any failing unit tests if the production server is losing thousands of dollars per second. Just push it out the door. I know it may not be perfect, but it's probably better than what we have. Alternatively, maybe our policy is very specific and identical there to say if there are any concerns in our software, it is not good enough to deploy. Well, what if the software running is bad and the software that we just built is also bad? Now, do we just shut it down? Do we hobble along? Which worse is more worse? This is not just a binary switch. We can't just say, there is a failing test we must not deploy. There are certain scenarios where deploying anyway is still tolerable. So, how we doing? Thus far, we've talked about pretty standard stuff. Unit testing, integration testing, policy validation, static code analysis. So where's the serverless? Where's the container in this? Yeah, let's pivot into that, container scanning. Container scanning is the process of looking through our container to identify all of the software that is installed in it, cataloging that software together with its version, and then comparing that software list to a list of known vulnerabilities. Now, the cool part is, as we go grab that list of installed software, we don't need to rescan our container again because it's ephemeral, isomorphic, and deterministic. It doesn't change. Once we know the software that's installed on our container, we know all of the content there. Now, it's possible that other content could be installed on our container, log4j. But if that's the concern, we need to kill off that container and spin up a new one. That's the benefit of ephemeral, isomorphic, and deterministic hardware. So container scanning. We go grab a list of all of the software together with its versions, and we compare that against a vulnerability database. So when should we scan? Now, the scanning process does take some time. We basically need to go look through the OS, going and grabbing apt packages or dev archives. We need to look through our software, looking for the packages and libraries that we downloaded. Perhaps that's through NPM or through gem. And we need to then collect all of that content into a place. So maybe it takes 10 minutes. Now, if the goal of our build is to run in 10 minutes, then can we run it in the build. Maybe we can start it in our build process, and that's great, but maybe we can't wait for it to finish in our build process. Next up, we could, as we publish our containers into our private container registry, we could run a scan on all the software in that container registry. Let's look for all of our new containers that we don't know their contents yet, and let's go run that scan. Once we've identified the software in each container, we can compare that to our vulnerability database. And we could also compare that to all of the containers that already exist. When there's a new vulnerability detected in the world, we can go look through our inventory of running containers and all the software running on them. Which one has log4j in it? We know exactly which one has log4j. We inventoried all of our containers. That's perfect. So we can scan the container registry. Now, the cool part about scanning the container registry is that we capture all of the things that are built. Now, if we grabbed it in the build pipeline, then that's perfect, but the assumption of scanning inside the build pipeline is that everything runs through the build pipeline. Are you running any off-the-shelf containers? Nginx or Redis? Those didn't go through your build pipeline. So we can't just assume that the build pipeline will catch everything. So we might look to our container registry. Now, the assumption of scanning our container registry is that everything flows through our container registry. Are we pulling anything from Docker Hub or any other public registries? Do our Helm charts reach into any public repositories? If so, then maybe the container registry isn't enough. Or maybe we have a corporate policy that says, let's pull them from all those external resources and cache them in our local repository as well. So next we could look at Kubernetes webhooks. Let's come back to that one because that one is really interesting. And finally, we can take a look at all of the clusters running in our, all the containers running in our cluster. Now, if we're looking at all of the containers in our cluster, arguably it's too late. It's already running. But if we pulled things from an external registry, or if we built them in another process, then maybe this is the first time we've seen that container. So maybe we need to run our container scan here too. Now the cool part is because these are deterministic hardware, they're going to be identical every time. If we've scanned that Docker image hash, we already know the content that's in that image. And so let's quickly run through our list of containers, identify the image ID for each one, identify if we have the software there, and if so, then we've already scanned it. We're good. That scan doesn't take 10 minutes. That scan takes 10 milliseconds. That's pretty nice. So maybe we put our scan into all of these places. Now, yeah, if we don't know what this container is yet, it may take 10 minutes to inventory it. But once we've identified the contents in our container, we can compare that with our vulnerability database, and we know if it's time to evict this container and take appropriate action. Let's double click into Kubernetes webhooks because that's really fun. Here's the process a container, or in this case a pod, goes through as it launches. Now, we have a whole lot of internal pieces inside of Kubernetes that takes care of getting from one step to another, but we do have two spots where it reaches out to external services. The first one is the mutating admission webhook. The second one is the validating admission webhook. In the mutating admission webhook, it sends the YAML, or in this case JSON, to each subscribed API and says, would you like to change this? This is a great place to inject sidecars, perhaps inject references to secrets. This is the perfect place to get that YAML up to speed. The next place is the validating webhook, and that's where it calls all of the subscribed webhooks in parallel and says, here's what I'm going to launch, go or no go. Hey, that sounds familiar. Let's put that right here. Let's put our container scan results right here. If we've seen the container before, if we've scanned its contents and identified if this container is good or not, we can make the choice right here. And we can say, nope, this container is not good enough to run. We're not going to schedule this pod. The beauty of putting it right here is that it can't launch in our cluster if we don't give it permission to do so here in this validating webhook. Now, if we haven't seen this container before and we're doing that 10-minute scan, perhaps the validating admission webhook is going to time out. So perhaps we say no, and then it reschedules it in a minute or 5 minutes, and then maybe we've finished by then, so then we can say yes. So there's some concerns to if we've just barely seen this container right here in the validating admission webhook. We might have some pods that don't schedule correctly because we haven't scanned them yet. But if we have scanned them in the registry or begun the scan inside the DevOps pipeline, then by the time we get here, we're really only validating that the software in our list meets our policy of exposed vulnerabilities. That's perfect. So we've now gotten a process where we can take a look at all of the software inside of our container. We can catalog that together with the container image ID and all of the versions of all of that software. Then let's compare that to a vulnerability database. Now, once again, I'm not here to sell software, but here's a list of tools that you might want to choose. This will definitely get you past the blank page. Grab these slides from robrich.org and click through each one and see which one matches your needs, either from a compliance standpoint or from just a preferences or comfort standpoint. The one that's not listed, if you do a docker scan command, it will actually call into sneak, which in hindsight, I should update this slide and put in sneak. Now, I don't want to pick one, but for the sake of demos, I'm going to pick Anchor. So let's talk about Anchor, more so about the methodology of how we would integrate container scanning into our process, and less about the implementation of Anchor. But how do you get started with Anchor? Anchor is free and open source, part of the reason that I chose it here. It runs as microservice containers. So maybe you launch Anchor in your cluster. Maybe it's running in a dev test cluster rather than your production cluster. But it's great at being able to run through these things. And because it's microservices, then it'll probably fit really well with the other tools that you have running in your cluster. Now, we'll do a software inventory, both of operating system packages and app packages. The cool part is if your app is a .NET app, for example, and you're also pulling in some NPM dependencies, then you'll have OS dependencies, you'll have your applications dependencies in NuGet, and you'll also have your NPM dependencies, and it will catalog all three. Or perhaps you're running a Ruby app or a Python app, it'll reach into those libraries as well. Once it's inventoried its list of software, it will compare that against the list of vulnerabilities in its database, and you can now see what vulnerabilities exist in the libraries that you've chosen to consume. Now, this doesn't say that your app is not vulnerable. We had static code analysis that might tell us if our app is vulnerable, but this tells us if our dependencies are vulnerable, or rather, if they're known to be vulnerable. Now, Anchor is not fast. It takes about 10 minutes to run, but you can queue it, and then you can go on and do other things, and then come back and get the results. The Anchor docs are not great. They do get it done, though. So if we head over to the Anchor docs, grab the slides from robrich.org, and click on the blue link, then we'll be able to download this Docker Compose file that gives us all of the details that we need to be able to spin up all of the Anchor microservices. Either Docker Compose up or then do the Docker Compose up. That gets the things running. Flipping Docker Compose into Kubernetes YAML files, you could use kcompose, and that will just convert it, which is really nice. Once you've got it running, then you could either use Docker exec, or you could pip install the Anchor CLI, and now you have the Anchor CLI, which is the way that you interact with Anchor. Now, some products expose REST APIs, some expose CLIs. In this case, I think the CLI works out pretty well. And then ultimately, now that I have the CLI, I can run commands. So our first step is to go grab that vulnerability list. We run Anchor CLI system status, and then Anchor CLI feeds list. And when we list the feeds, it notices that it doesn't have the definitions for each feed, and it goes and tries to download them. Now, it says in the docs, it may take up to 10 minutes. If only. I began on the 20th, and I ended on the 23rd. It was only 10 minutes, right? Yeah, it took me about a week. Well, 4 days of it just running and cranking to go download all of the feeds. I don't know if my behavior is unusual, but I did enjoy that in their docs, in one spot it said it may take 10 minutes, and in another spot it said it may take a few hours. The cool part is once you've downloaded that vulnerability database, you already have it, and grabbing updates is really easy. It just needs to grab the diff from what it had before. But it's the vulnerability database for all the versions of Linux, Alpine and Red Hat and Ubuntu and others, all of the package definitions, NuGet and NPM and Ruby gems and Maven. And so it has a database for each of these registries and all of the packages that exist in it for all of the versions of Linux, which is really interesting. So it's not a small data set. Okay, so once we've got the Anchor CLI available, then we can start to kick off the commands that will do stuff. Now, here's the commands that Anchor exposes. We can say Anchor CLI image add. That's how we start the process. And that is non-blocking, so it'll return immediately, and we can then take additional action. Now, if we choose to wait for the image, maybe 10 minutes isn't our ideal build time, so we're okay with the scan running in series in our build, then maybe we can kick that off and then just wait for it. So Anchor CLI image wait will pass in the name of the image, and that will then wait for that image to get scanned. Now we can go grab the summary, Anchor CLI image get those details, and it will give us kind of a quick summary of all of the things. It outputs in JSON, by the way. We could also ask for the vulnerability list rather than just the entire list. And in that vulnerability list, we can also pass in the types of things that we want. The OS, NPM, gem, etc. In this case, I chose to pass in all. So it'll give me all of the vulnerabilities that it knows about all of the packages that I have installed. All of the packages at my current version that are installed. And then finally, I could just grab the list of installed software. Now this is perfect. Go grab this list, stick it in an external database together with the image hash, and now whenever I want to identify, is my system vulnerable, I can go look through all of the running containers that I have, go grab all their hashes, grab a query in this database for all of the software installed in those hashes, compare that with my vulnerability database, and I know exactly my exposure level. That query happened without touching the containers. That's pretty cool. Wouldn't it be cool if the CTO walks in and says, okay, we've got this new vulnerability, which containers are susceptible to this? And we can say, nope, we're good. That's pretty cool. So we can also do this process with GitHub Actions. Now the beauty of using GitHub Actions as our build system is that it is cloud hosted, and we can run a certain amount of builds for free. And they will keep the vulnerability database up to date. So that big week-long process of downloading the definitions, that's already done. That is nice. So all of those commands about spinning it up and waiting and all those things got compressed into one GitHub action where I just pass it the name of my image. I could optionally pass it my list of my Docker file, include app packages, of course. And then they also have this fail build option, which I couldn't get to work. We'll see the experiments when we get to the demo. But I kept passing in fail build true to say, if you have a vulnerability of above this threshold, then fail the build right here. And it was like, yeah, that's good. So it runs the scan, and it grabs the results. And so now I'm going to go look in that Anchor reports directory, and I can just echo out the contents of each file. Now I'm going to specifically run this if always, because if I've chosen to fail the build here, then I run the results here. On a failed build, I would not have any results. That would be bad. Hey, the build's green, here's the results. The build failed, sorry. So let's dig in. Now, I have links to both of these repositories right here. Let's pull those up on GitHub. The cool part about this repository is that the content of this GitHub Actions build is identical. I just happen to check in a vulnerable library in one of the paths. So we can see that this is the pass one, and here's my experiment of trying to get it to fail in interesting ways. You know, can I get it to fail on if fail true? And so you can see that I failed a bit. But ultimately, this one passes, which is excellent. We could also take a look at this one, and we can see that when I committed that vulnerable library, I got this one to fail. One thing that I noticed with Anchor is it doesn't enumerate all of the files on disk looking to see what library they were part of. It only enumerates my package list, my package manifest. So it did great at looking at my packages.config for NuGet, and it did great at looking at my package.json for npm. But if I just grabbed jquery.js and put it on disk, it was like, yeah, that's fine. Yeah, that's where we lean on the static code analysis tools. But ultimately, have that package JSON in place so that you can enumerate your external libraries as well. So both of them use this identical build file, and we can take a look at what that build looks like. But before we do that, let's take a look at what we might do with a regular on-prem build. So here's my build.sh. Maybe this is build.bat. And maybe Jenkins or TeamCity kicks off this build. And so right now we can see it's going to do a Docker build, it will do a Docker push, and do kubectl apply to get that pod into Kubernetes. So we want to add container scanning. Now we looked at the command lines that we saw previously, the Anchor command lines. So let's flip over to the build that is done. We still have our Docker build. We give it a name, and we'll give it a version, and we'll tell it we're building in the current directory. Now that we've got that image, now let's call Anchor CLI, and we will pass in that image name and version. And we will also pass in our Docker file so that it can do some additional checks to validate, what did I choose to install and then maybe later remove, or did I put it in an unusual directory? In this case, I chose to wait. So I'm waiting for those results. Yeah, the build is spinning for some time. So maybe I do this, and then I kick off all of my integration tests, all my Cypress tests, all my SonarQube tests, and then I wait. That could be cool. Okay, so once I've waited, once it's finished, it's gotten the results, I'm going to go grab the list of vulnerabilities and stick it in this vuln.json file. That's my list of vulnerabilities. Now we can apply our policy. Are we going to say all unit tests make the build fail? Are we going to say that any vulnerability over a certain level, maybe medium or higher, makes this build fail? In this case, I'm going to go look for any vulnerabilities anywhere. And if there are any vulnerabilities in this vuln.json file, I'm going to say, nope, we're done. Yeah, that's probably a little bit too aggressive, but that was my choice. And next, I'm going to go grab the content and put that in content.json. Now, of course, if I said fail the build, I haven't pushed it to the registry yet, so maybe I don't need to keep track of this inventory of this container because, well, the container is going to die in a minute. But if I do pass it, then I want to go grab that content, and I want to go stick it in some build artifact location tagged with my image SHA and the list of software inventory together with their versions. Now that I've passed this container, it's good enough to deploy. Now I'm going to Docker push this into my registry. So now I've made the assumption that anything in my registry is good enough. Now I may want to kick off the Anchor scan on my registry as well, but I've now got a clean container in my registry. Okay, so let's apply this to Kubernetes, and kubectl apply will go schedule that pod. Perhaps we have that validating webhook that's going to go look in this vuln.json and content.json or the database that I chose to put them in, and validate that this image hash is clean and thus kick off the process. So by adding these anchor CLI commands into my on-prem build, we were able to add container scanning to be able to understand the content and the details of our content. So here's the content.json, and this isn't spaced very well, so just mashed it, but here's all of the details of all of the packages. So if we look at particular things, here's the content for my OS. We can see that here is my package name right here. And here is the version of that package. That's perfect. So we can enumerate all of the different packages that we have installed. It's also harvesting licenses where it can, which is really elegant. And so now I've got all of the content for my operating system. In this case, I also have some content for NPM. Here's the location on disk of where that is relative to where it's scanned. Here's some other packages that we have installed. And then ultimately, when I'm looking at my vulnerability, here's my list of vulnerabilities. So here's all the policies that it used when it did it. And let's go find a vulnerability. Action warned, so that one's probably okay. But here's the, nope, here it is. Get me past the warns to, there we go. Policy evaluation. Ooh, we are running our Docker file as root. Glad it grabbed that one. That's pretty cool. I'll scan all the way down to the bottom of this and status pass. It looks like this container is okay. So that was the on-prem build, and it was cool to be able to get Anchor to be able to run in our local environment and to be able to get things done. In a similar way, we can flip back over to GitHub Actions and take a look at the GitHub Actions build, and we'll do similar things. But instead of doing all of the Anchor CLI commands, we can just reference this Anchor scan task. Now, we're going to check out our content. We'll do a Docker build in the normal way. In this case, I've chosen to label it with the GitHub SHA. Now, the beauty of using the GitHub SHA as the version number is now we can walk through our cluster going, oh, here's the Git hash that I need to be able to check out the code at that version. That's pretty cool. So I've built my image, and now I want to kick off that scan. Here, let's reference that image right here. And no idea why fail build true doesn't work, but it doesn't. Here's their experience of outputting the results, just getting it in the build log. That's not a great solution, but I'm running it on if always to ensure that it always runs even if I failed the build. Now let's upload these build artifacts, the Anchor reports folder. So in a similar way that we would pass our unit test results, our JUnit files, we can also pass the Anchor reports. And then I'll go check it. Now, here's my overly aggressive check here to say, if there are any vulnerabilities anywhere, I want to evict this process. So maybe that's a little bit extreme. But that's the build that runs in both places. And so when I don't have vulnerable software, it succeeds. And when I do have vulnerable software, it fails. But it also took 11 minutes to build. Yeah, I exceeded that time frame. So the cool part about Anchor is that, and all of the image scanning software, is that it allows us to get that inventory of our containers and then compare that to a vulnerability database. Now the cool part is because our containers don't change, if we want to revalidate this container, we just need to look through the inventory list and recompare that to the vulnerability database. If the software in our container changes, we've got bigger problems. We don't run Windows Update in the container. The way that we get new versions is we rebuild our container based on our Docker file. So now what do we do with this information? Now the cool part is that we can now rebuild our image to be able to get non-vulnerable software into place. So perhaps we should rebuild our images frequently. Maybe have it run on a cron once a week to go get the latest versions of things. Now that does mean that we can't check in our package lock.json or our yarn.lock. We need to give it image ranges, semver ranges. But the beauty there is that if we have confidence in our unit and integration tests, then we ought to be able to upgrade our dependencies automatically and push them into production without incident. Now that is an assumption. At the point where our unit tests have failed us, let's go back and build more robust unit tests to be able to get more confidence in our system. But let's also expose this build button from developers into operations. Let's imagine a scenario where the next version of a vulnerability comes out. Operations can go look through the catalog of installed software on running containers, validate which containers are vulnerable and have patches, and then go into the DevOps pipeline and push rebuild. It'll rebuild the content that is in the main branch, the deployment branch, and redeploy into production. And the vulnerability is patched. And development didn't need to wake up and do that. Operations was able to do that. That's excellent. If operations can kick off DevOps pipelines to build non-vulnerable versions of the software, then we can get new versions into production without involving developers. Now, if the unit tests or integration tests fail because the new version is incompatible in a certain way, yeah, now operations needs to get developers involved to be able to get this software patched and in place. Now, what if we identify that there's a vulnerability, but we also identify that there is no remedy to this? Maybe we're hard-coded into an older version of the software, or maybe it's just not patched. Should we block our deployments? What if there's a vulnerability that has no cure? Should we just lock down the world? Or maybe should we hobble on as best we can? Maybe the new version is better. Not perfect, but better. Now this is a decision you'll need to make in your organization. What's your tolerance for deployment? Is it okay to have medium severity vulnerabilities if there is no remedy? Or are we going to say that if there is any vulnerability in the container at all, we're just not going to deploy? Now what if we have a vulnerable system in production and we have no new image that's good enough to push? Do we shut off the site? I would invite you to have this conversation with your DevOps team, with your InfoSec people, and make that choice. What is your tolerance for vulnerabilities within your system? What are the exceptions that you need to justify? If we're losing a lot of money because the software is vulnerable, then we need to push out even if our unit tests or integration tests fail. That might be a conversation worth having. So we saw that Kubernetes really only protects itself. Docker only protects itself. And we secure the containers. We secure the content running inside of our containers. Container scanning is a great tool to be able to do that. Now the beauty of adding container scanning is that we just need to inventory our container in one spot. And once we've identified the contents of our container, it will not change. Given a hash, we know exactly what's in our container. Given that list of inventory, we compare it to our vulnerability database, and we know our exposure. That's great. Container scanning is an excellent piece to be able to add to your InfoSec piece to be able to gain a level of confidence with the containers in your system. I would invite you to go experiment with container scanning software, pick the one that works for you, and implement it into your DevOps pipeline and your Kubernetes control plane. This was a lot of fun. Thanks for coming. Any questions about the content I've presented? What did I miss? What should I add next time? Yep.
I'm pretty new to container security, pretty much containers in general. At least our organization is. I know we're pretty early on as far as scanning it, but you talked about like integration testing and
great question. So we kind of skimmed over the unit and integration testing piece. How might I add that into my system? Excellent. Let's flip over to this build script where we did that Docker build, we did the Docker push, and the kubectl apply. Now the interesting thing is here, where's our, oh, I don't have my Docker file here. Inside my Docker file, I might, let's actually create a new Docker file from mcr.microsoft.com/ASP.NET, or no, SDK 6.0-Alpine, copy all the things, run .NET restore, run .NET build, we'll build in release mode, run .NET test. I've never built a Docker file this fast before, but this is awesome. Run .NET publish -c release -o dist from mcr.microsoft.com/ASP.NET 6.0-Alpine, copy --from equals build, all the -dist to the current folder. I need a work dir of /app, and I also need a work dir here of src, and then I will set some environment variables, and then I will cmd .NET my DLL. Okay, so there's our Docker file. And this Docker file does all of the things. Here's the spot where I'm running my unit tests. Now the beautiful thing about running my unit tests here is that if my unit tests fail, I never publish, which means I never build the second phase. Oh, I needed as build there. I never got to my second phase. I never got an image. So here's where I like to run my unit tests. Now, wait a minute. My tests may build extra things. They may put extra files in my thing. And so I may choose to say something like this from maybe I need to inject environment variables into my tests. So I'm going to say copy --from equals build, the dist folder into my current folder, and cmd .NET test. And here's where it's like, yeah, this is an ugly way to do it, but that works. Now I have 3 stages. Now if I label this one as test and this one as prod, I can now build my Docker file differently. So here in my build.sh, perhaps I do a Docker build, and that's my regular build. And then I also do a Docker build, and I think it's stage equals test. I'm not positive about that. And it will only then go grab the new pieces associated with that. And now I could say Docker run, oh, this one is -test. Docker run that, and I could also pass in some environment variables. So maybe I say connection strings my DB equals some server, and I probably need to put quotes around that because it's gonna, but you know, now I can start to pass parameters to my tests, which is pretty cool. I really like to do them right here, if at all possible, but if you need that additional configuration, then that's one way where you can kick off your unit tests in really interesting ways. Now similarly, I'm doing this before I push the container to my registry. So if my unit tests fail, then I'm not getting any farther. Now the cool part is I can do similar things with my integration tests. So I can say docker run Cypress tests. And so maybe I run this -d. That will give me the image ID. Let's run that. So I'm going to run my app, and then I will run test ID equals, let's run the Cypress tests. That will output various results. So maybe I also need to say -v test results to data results, wherever I've got that test results piece that actually needs to go there. And now I've got those two containers running. The one is hammering the other, and so I'm able to kind of get some integration tests. Maybe I'm running a Docker Compose that kicks up my entire stack here, but now I can run Cypress tests, or I can run SonarQube tests, or I can run other tests that need access to an entire system. What's really cool in this part, spin up a copy of your database too. Now I've got a throwaway database that's really cool. The cool part is at the end of all of this process, I've now run all of my integration tests and I haven't left the build yet. So I validated that this container is good enough, and now I push it to my registry. We did this inside of a build file, a script, but we could do similar things inside of GitHub Actions files, where we could do, this is just running script commands, so we could just execute those lines, but we could also create additional tasks to go kick up cross-browser testing or reach into other services that way too. That was a great question. Did that answer your question?
Yeah, that's great. Thank you.
Perfect. What other questions do we have? Any questions online? Yep.
I'm just curious what a more typical runtime would be for that process.
Ooh, good call. I did say Anchor was slow. What is a better way to do that? Is there faster software? No. Anchor is decently typical in this space. It's just the process of spinning up the container, running an apt list, enumerating all of the possible places where package.jsons could be, or packages.config. We also don't know, is this a Ruby app or is this a Python app? So let's go look for packages from all the different places, and then enumerating all of that and collecting it, it just takes time. So Anchor isn't any better or worse at this. It's just that process takes a while. Great question. What other questions do we have? Any questions from online? Not yet. Well, if you're watching this recording later, you can grab these slides on robrich.org. And if you think of a question tomorrow or next week, hit me up on Twitter at @rob_rich. This has been a lot of fun. Thanks for coming.